we will discuss molecular structure of pyrrole. In pyrrole, the carbon is present its electronic configuration is 1s2, 2s2, and as it has 6 electrons, the other 2 electrons are present here, 2px, 2py and 2pz. After hybridization, the electronic configuration is like this. One s2, one electron from 2s orbitals comes here in 2pz. So every orbital is occupied by one electron. These orbitals show hybridization, sp2 hybridization, or we can say संकरण अवस्था में आ जाते हैं. By this hybridization we get 3 sp2 hybrid orbitals and one unhybridized 2pz orbital. Having 2 electrons. Similarly, nitrogen as it has got 7 electrons, we can write down 1s2, 2s2, 2px, 2py and 2pz having 1 electron each. After hybridization, we can write down the structure like this. One s2, 1 electron from this orbital goes to 2pz orbital. Two px, 2py and 2pz. Again, these 3 orbitals shows hybridization sp2 type, forming three new hybrid orbitals sp2 type. One 2pz orbital having 2 electrons. So we can see the structure of pyrrole. These 4 carbon atoms and 1 nitrogen atoms are gone under sp2 type of hybridization. So each carbon atom is showing sp2 hybridization, and its hybridized orbital overlaps with the orbital of hydrogen, forming a sigma bond. So we can write down C this carbon atom undergoes sp2 type of hybridization. These sp2 hybrid orbitals overlap with each carbon atom, and this sp2 hybridized orbital of carbon atom overlaps with 1s orbital of hydrogen. Similarly, we can see here also this carbon atom having sp2 type of hybridized orbital overlap with 1s orbital of hydrogen. Third sp2 hybridized orbital of this carbon atom overlaps with the sp2 hybridized orbital of this carbon atom. Similarly, if we see this carbon atom, the third sp2 hybridized orbital overlaps with the 1 sp2 hybridized orbital of another carbon atom. Now we can see this carbon atom having sp2 hybridized orbital overlaps with the sp2 hybridized orbital of nitrogen. The pz orbital of nitrogen atom having 2 electrons is at 90 degree in z axis, and sp2 hybridized orbital, another sp2 hybridized orbital overlaps with the carbon atom's sp2 hybridized orbital. Here one pz orbital, sp2 hybridized orbital of nitrogen atom overlaps with the 1s atom of orbital of hydrogen atom. So we can see all carbon atoms of pyrrole. Here one sp2 hybridized orbital overlaps with the hydrogen atom, and here also one sp2 hybridized orbital overlaps with one hydrogen atom. So it exists in one plane only. These sp2 hybridized orbitals are at 120 degree apart from each other, and they are found in one plane only. So finally they make the structure like this. If we see the pz orbitals of carbon atom and nitrogen atom, we see that they overlap collaterally, forming pi bonds. Here we can see that these sp2 hybridized orbitals by overlapping forms sigma bonds with other carbon atom and hydrogen atom. But here we can see that the pz orbital overlaps and forming pi bonds. These are having one electron each, and this nitrogen is having 2 electrons. Now they overlap like this, and as it exists in one symmetry, these z electrons, z orbitals having 1 electron each on carbon atom, so 4 total electrons, and 2 electrons from pz orbital of nitrogen, so 6 electrons exist, and they form by overlapping, they exist above, and if this exists in this plane above and below the board, forming a sextet of electrons. These 6 pi electrons shows aromatic character of pyrrole. Now, as nitrogen is more electronegative than carbon, the circular form of this overlapped pi orbitals are distorted, or it comes like in this shape. pz orbitals overlaps and they the 6 electrons, 4 from these carbon atoms and 2 electrons from nitrogen revolves in these orbitals. and this shows their aromatic character, or these 6 pi electrons are responsible for the aromatic character of pyrrole.